Good morning, everyone. I'm pleased to open this conference session this morning, and I will present on behalf of myself and the two co-authors of this presentation, this sharing of experience, which is Ms. Alisha Pengel, and she's working for City Pesca, and Yann Laurent is working with the FAO, and both of them have been providing considerable support to Suriname over the last couple of years when it comes to improving fisheries data collection and data management. So when we felt that it would be valuable to share some experience that we had from Suriname. So as we all know, fisheries data and statistics are very important. We think for two main reasons. On the one hand, we need them to comply with various reporting requirements for national and international organizations, and to ensure that fishery products retain their market access and can be exported. On the other hand, of course, we need them for fishery management purposes and to get well-informed management decisions. For example, to perform stock assessments, define optimum levels of fishing effort. So in Suriname, the marine fishing sector is quite diverse. There is fleets operating in estuarine, coastal, and offshore waters, also including the high seas, with a total of approximately 1,000 artisanal vessels and some 250 industrial and semi-industrial vessels. So all these fisheries are multi-gear and multi-species, targeting shrimp, groundfish, but also large pelagic fish. And so as you can imagine, the data collection across all the vessel gear types and across all the different landing sites in the country is quite a challenge. So a few years ago, the situation was that the self-reporting by the industrial fleet was quite poor. And on the other hand, the sample-based data that was collected by the fisheries department itself, the erasing of the statistics was basically done on best guesses basis. The statistics itself were only produced on a yearly basis, and there were no specific stats when it comes to different species, fleets, vessels. There was just total shrimp and finfish production. As it comes to the data itself, it was scattered in numerous Excel files on different PCs, and the registry of vessels and fishers, although it was in an Access database, it was just on one single PC with no backup. So it was clear that an improvement process was needed to review the data collection methods and the reporting practices. And in doing so, over the last couple of years, there were a number of, we call them modern tools, introduced that I will discuss in the next couple of slides. So tools or approaches that are quite novel, at least for Suriname, when it comes to fisheries data collection. The first one of them is the introduction of digital forms for data entry, and we have been using for a while now Kobo Toolbox application, which is basically a platform to create these XLS forms, which allow you to enter data on a mobile device, and the data is then sent to the Kobo Toolbox server, where in the office you can download the data as an Excel file. So in doing so, we have noticed that actually the data collectors are quite happy with this because the data entry itself is made much easier. Instead of first writing on paper, then taking the paper to a PC and fill in an Excel file, now you basically go to a step-by-step questionnaire. In that way, the data collection is less prone to error, and you can also restrict the input. For example, you can put in drop-down menus to choose from a list of vessels, for example, or you can specify the allowed range in terms of the length of fishing trips and so on. So you don't have this kind of errors that were quite common before. When validating the data, when in the Excel, in the Kobo Toolbox application online, you also have this data validation workflow where you can approve data or put it on hold and so on, which which is quite a user-friendly interface. So that's sort of our first innovation. The second one was the introduction of scripts. So when the Excel files are downloaded, there is a number of data checks that need to be done and quality control, which previously would be done manually. But now we have some scripts, which in our case are written in Python. They could also be written in R or C++ or any programming language. By coincidence, we're using Python because we had some colleagues that are proficient on that. But so what these scripts do is they perform data quality control. So they check the data against reference data. Again, for example, the list of known vessels, or against acceptable values for certain parameters. And also, the scripts would compile different Excel files into one bigger file that we can then upload to our database. The experience with using these scripts is that we now have a good documentation of what happens with the data once it's downloaded. So basically, the script writes down every single step that happens to the data, and it makes the workflow transparent and also reproducible. So when you have some turnover of staff, if they get the skills to read the script, they can basically perform the exact same tasks. And if we compare that by clicking different buttons in Excel, it's not documented. So a script basically documents the procedure that happens with the data. Another advantage is that you can apply the script to recent data, but also to historical data. If the raw data is available, you can perform similar tasks on old data than you're doing on your new data. And the final sort of innovation that we had in Suriname is the introduction of a new database, central fisheries database. In our case, we have set up the Calypso database, and that is a system that is promoted or supported by FAO, which is a web-based platform for safe storage of fisheries data and also for the calculation of fisheries statistics. So the advantages here that Calypso is a web-based application that can be accessed from anywhere. You can have different users with different user rights. And most importantly, all the fisheries information, including vessel registries, fishery-dependent data statistics, are securely held in one place. It is also a fisheries management and information system. So it allows also to check between different divisions in your department, for example, between statistics and licensing division, to check whether the vessels that you collect data from are actually licensed, for example. And in that way, you get more efficient fisheries monitoring, control, and surveillance. So it has advantages beyond just statistics and data. So overall, our experience with these tools have been positive. It's worth noting that these are all open source software solutions. The Calypso platform developed by FAO will also in the future be published as an open source software. And important here is that the principles of the data workflow is important. And as mentioned before, there are alternatives to the ones mentioned in this presentation. It's worth keeping in mind that redundancy and backup is key as we work with digital data. Stable internet connection is important. And that, of course, we need the technical capacity. We need some technical capacity in programming. But it's worth noting that there are many sources available on the internet for self-study. This is my final slide, Lester. The final remark is that these tools are now freely available. They have the potential to make fisheries data collection more user-friendly, more efficient, and more accurate. So it might be time to rethink your system. And I want to stress that it's important to change experience and knowledge. And that's sort of what motivated us to present sort of our progress here. We are not definitely the experts on all of these applications, but it would be nice to get in touch with others that are experimenting with these tools and to learn from each other. Thank you very much.
Thank you very much, Mr. Willems.